One thing I've been glossing over in some of my earlier videos is just how much current is required to produce, this 300 or 400 watts of energy at 20 meters. For example, through this inductor, we have 50 amps of peak current, or 100 amps peak to peak, roughly 35 amps RMS. What kind of inductor can handle that? And likewise, the capacitor has to handle equal amounts of current. We're talking in excess of 50 amps, and this is just a little surface mount board. So the parts I like to use, Coilcraft makes these flat wire air core inductors. Now, air core is nice because it's not going to saturate at high currents like some sort of ferrite cores. Also, you don't have to worry about ferrite losses, but you do have to worry about skin effect. Depending on the frequency of your RF, you're not going to be using all of this copper in these inductors. You're going to be using roughly 10% in this case, but it's going to vary based on frequency and inductor construction. But this series of high current power inductors from Coilcraft is great. You can see here, if you're willing to, put a little fan in there, dealing with 50 amps of current is something that they're actually designed for. Then comes the capacitors. I've been using these Vishay parts. Their 1111 package is great because as you can see, a lot of the capacitors are rated for north of 10 amps RMS. So if you put, I think I'm putting 5 or 6 in parallel to split that load across multiple parts. So, achieving something like 50 amps of peak current in these circuits is actually quite achievable. And when you're switching the RF energy, just standard relays are typically only about 75 cents a piece. So it's really not all that daunting. And one thing I wanted to mention is I mentioned the antenna tuner, but I didn't really talk about the automatic portion of it. How do you make an automatic antenna tuner? Well, you have to know a little bit about vector network analyzers, and you're going to need some sort of directional coupler. In my circuit, I'm using, let's see, that's the wrong one. Let's go over here. In my circuit, I'm using this TCD-18-4X Plus from Mini Circuits. It's a fantastic part for, depending on volume, just a couple of bucks or less. The one thing you do have to know, though, is it's going to have this coupled port and this external termination port. You can actually use this as a bidirectional coupler. If you have a good low SWR load on both sides, which I accomplish with just a couple of cheap 10 dB pads, then you can actually just use a single coupler for getting both your forward and reverse power and phase. And once you have that information, Mini Circuits put together a great application note on basically all of the math behind vector network analyzers. So, it's pretty math heavy. You have to be pretty comfortable with complex numbers and matrices. But, pretty straightforward stuff. And then you have basically a low-cost VNA right inside your radio. So if you decide to design your own automatic antenna tuner, or just want to know about how VNAs work, or how to choose and find parts for some high-power RF projects, these are some good places to start. Like and subscribe for more content. I'll try to make some more videos soon.